Inverses of trigonometric functions. These work very similar to when we've done other inverses, where we have switched the domain and range that we said when we were trying to find inverses of functions, that we could switch the values of x and y and solve for y, or when we're looking for coordinates, we're switching the values of x and y. So the same thing applies when we're talking about trig functions. So first of all, when we look at the functions themselves, we could look at them this way here. That's in this chart. It says here's the function. It says sine of theta equals a, cosine of theta equals a, tangent of theta equals a. And so if we're going to find the inverse, we're switching the domain and range. So to switch the domain and range in this case then, or independent and dependent variables, to get the inverse of sine, so the inverse sine would be a equals theta. So the inverse sine of a is equal to theta. And this is how it works. That remember that theta is an angle, and then the number we get when we do sine, cosine, or tangent of theta is a ratio. Okay? Or a decimal number could be like 1/2, square root of 3, square root of 3 over 2. Okay? But when we do the inverses, we'll do the inverse of a ratio to get an angle. So if you know the angle, you use sine, cosine, or tangent. If you're trying to find an angle, you'll use inverse sine, cosine, or tangent. And you'll notice that on your calculator, when you look at it, that you have, come on. That when you look at sine, cosine, and tangent, right above them, in the blue is inverse sine, inverse cosine, inverse tangent. So if I know the angles, I'll use sine of the angle or cosine of the angle to find the answer. If I'm trying to find the angle, which is the things that we'll be working on today, we'll use the inverses then to find the angle. So we're going to find trigonometric inverses. So here, example 1a says find all possible values of inverse cosine square root of 3 over 2. So there's two steps to this. Okay. The first step is find all instances that occur between 0 and 2 pi. In other words, most of the cases we'll be looking at, we're talking about the unit circle. Okay. Then after we find the cases that are between 0 and 2 pi, we're going to find all the angles that are coterminal with those angles. Okay. And if you remember, coterminal angles are ones that either differ by 360 degrees or differ by 2 pi. In all of them we're going to be working with, unless it says otherwise, our answers are always going to be in radians. Okay? Unless it specifically tells you to find answers in degrees, you're using radians. So do not set your calculator to radians. Okay? I'll tell you when, or it will tell you when. Okay? So look at your unit circle. Where does cosine equal square root of 3 over 2? Because when this says inverse cosine square root of 3 over 2, we're trying to find angles. Okay? Okay? And we're looking for radians. No, that's 3 pi over 2. That's not square root of 3 over 2. Okay? Where does cosine equal square root of 3 over 2? Okay? At 30 degrees and at 330. The only problem is our answers need to be in radians. So what are the radian measures at 30 degrees and 330 degrees? Pi over 6 and 11 pi over 6. Okay? Oops. So we get pi over 6 and 11 pi over 6. Now, we need to find all the angles that are coterminal with those angles. In other words, if I start at pi over 6 and I go around I take this and I go around the circle once, okay, I'm still back at pi over 6, right? Except I've added, to get back to this spot, if I go all the way around here again, okay, I didn't go 360 degrees. I went, nope, 2 pi. Okay, we're talking about the distance around the circle in radians, okay? And if I go this way around to get back there, I also went 2 pi. Okay? So what happens is that every time I go around the circle, I'm there, and every time I go around the circle, I'm doing what? Adding 2 pi, all right? And I'm doing it from, either I can do it from pi over 6, and also the same thing applies at 11 pi over 6. So the answer I'm going to have here then is going to be pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. Okay? So this takes us multiples around the circle to get to land at those spots, but you also have to make one more statement where n is an integer, because it specifically has to be an integer because I have to go around the whole 2 pi. I can't go around partial pi's. So the answer to this question is pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n, where n is an integer. Because every time I land at pi over 6, cosine equals square root of 3 over 2. Every time I land at 11 pi over 6, cosine equals square root of 3 over 2. And that's a circle, and circles do not end, right? They go on forever. Okay? And the same thing here. We can go on and on forever. Okay? And let me show you another reason why. If you take your calculator, and if we graph cosine, and for this instance, make sure your degree is in, or your mode is in radians, not degrees. Check your mode, make sure it's in radians. And if you press zoom 7, not 6, but 7, and look at the graph. So this graph is going to go on forever doing that pattern there. So it's going to keep hitting square root of 3 over 2. You know, it's going to hit it here. It's going to hit square root of 3 over 2 here. And then every time I get to that spot, it's going to hit it. So we have an infinite number of solutions. And the way to get every solution is by adding 2 pi n to each answer I get. All right, let's look at another one. Letter B says find all possible values of inverse cosine of negative 1/2. So let's help make this easier to find out, okay? Cosine is x, right? On my unit circle, cosine refers to x. And x is negative where at? When's x negative? Just x. When's x negative on a graph? Okay, in the second quadrant and the third quadrant, right? Okay, so I want to look over to the second and third quadrant to see where I get negative 1/2. And what radian measures are those? Okay, 2 pi over 3 and 4 pi over 3. Okay, that's where x is equal to negative 1/2. So I write those two answers down. Every time I hit those when I go around the circle, after I go a complete rotation all the way around the circle, I end up there, and that's where n is an integer. And you must make that statement. It will not be completely correct without the statement there. Okay? You cannot assume that somebody's going to believe that n is an integer. So all I'm doing here is, this is just another use of the unit circle then. Right at the moment. Okay? Okay, now, for inverse, sine, cosine, or tangent to be a function, they have to be restricted. Okay? If you remember back when we were doing the inverses with quadratics, we said at times that you had to restrict the domain so that we actually could find functions, because it would fail. What was the test that we said it would fail? Not the vertical line test, but the horizontal line test. And if you look at this graph of cosine, it fails the horizontal line test. So the inverse of cosine is not a function. So what we're going to do is we're actually going to look at restricting the values then to where it is a function. One thing you'll notice that when these were written here, these inverse relations, notice it does not say function. Okay? It says inverse relation. We're using lowercase letters for sine, cosine, tangent. When we use uppercase letters for them, that means that we're talking about functions, and for these to be functions, they have to have restricted domains, restricted ranges. So here's what's going to happen for sine. For sine to have an inverse, it's going to be restricted to be between negative pi over 2 and pi over 2, which is the right-hand side of your unit circle. All right, we'll talk more specific as we're doing this. Cosine. For cosine to have an inverse, it's restricted to the area between 0 and pi, or 0 and 180, which is the upper half of the graph on your unit circle. For tangent to have an inverse, it's restricted to between negative pi over 2 and pi over 2, also same as sine. All right, so the right-hand side of our graph. So for them to be functions, we have to restrict them there. So let's take a look at the graph itself on our calculator. And I'm going to start with sine because that's what they do. So here's the graph of sine. All right, this is not a function, is it? Okay, or the inverse is not a function because it fails the horizontal line test. But if I restrict it between negative pi over 2, and positive pi over 2, then I can take the inverse of that and I'll have a function. Because you'll notice, okay, if I draw any horizontal lines, will they ever intersect more than one place? Okay. They won't, right? Okay. But if I add to this, if I say, okay, well, let's go to pi here. Problem is, if I go to pi, it starts coming back down again, and it fails the horizontal line test in this region here. Okay. So for sine to be a function, our domain has to be restricted between negative pi over 2 and pi over 2. And I'm going to show you how this works on our unit circle. It's the right-hand side of the graph. For cosine, here's the graph of cosine. Fails the horizontal line test. But if I restrict the domain to be between 0 and pi, I'm going to get the positive and negative values. Look at your unit circle. What's the largest number that you can get for sine? The largest number for sine. Remember, sine is y, right? What's the largest y value on that unit circle? What's the highest point on that unit circle? 1. Okay? The biggest sine can be as 1. Okay? Go down to the lowest point on that unit circle. What's the smallest that sine can be? Negative 1. Okay? Let's talk about cosine. Cosine is x. Okay? The left is going to be the smallest, right? What's the smallest x value? No? Negative 1. And if I go to the right, the largest x value is 1. Okay? So for sine and cosine here, this goes from positive 1 to negative 1 in this region from 0 to 2 pi, or 0 to pi, which is the top half of our circle. Tangent looks like this. Here's what the graph of tangent, oh, let me give you more of it. Here's what the graph of tangent looks like. Now, it looks like that because there are asymptotes there, because on the y-axis, okay, at pi over 2 and 3 pi over 2, what's tangent? Pi over 2 and 3 pi over 2, what's tangent on your unit circle? It's undefined. It's undefined because we can't divide by 0 there. And when we try to divide by 0, we have asymptotes. Okay? Same thing works just like it did when we were doing rational functions. So I could look at from 0 to pi, like sine or like cosine has. And if I look at from 0 to pi, it looks like we have all the positive and negatives there. The only problem is that we have a break in the graph where the asymptote is. And I can't have that break in the graph. So I have to use the same ones that we do for sine. So that I have the negative values and the positive values along with 0. Okay? But there's no break in that graph. So, inverse trig functions. For it to be an inverse trig function, right, these are capital letters. Okay? Right? They use capital S, capital C, capital T. The domain for sine and cosine must be between negative 1 and 1. The range for sine between negative pi over 2 and pi over 2, or negative 90 and 90.
Domain is the
X values, the independent variables. For cosine, inverse cosine, for it to be a function, the domain is between negative 1 and 1. The range is between 0 and pi, or 0 and 180 degrees. For tangent, the domain is all real numbers. The range is between negative pi over 2 and pi over 2, but not including them, because at negative pi over 2 and pi over 2, it's undefined. So that's why they're using just less than, not less than or equal to here. So we need to take a look at our unit circle a little bit differently, okay? When we're talking about the inverse functions. So what we've got to do is I actually have to do this then. All right? And you, of course, you're not going to do this on your paper because you want to be able to read them. Is I'm going to take these and I'm erasing them. Because I need to think about going clockwise now. Okay? And if you remember when we talked about this very first thing, we were drawing angles, positive and negative angles. If I have negative angles, it means we go clockwise around the circle. Well, if I go clockwise, this angle here and this angle here have the same reference angle, correct? They're both 30 degrees. But if I'm going clockwise, this is now negative 30. So this is negative 45, negative 60, and negative 90 when I'm going clockwise. Or negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So when we're using the inverse trig functions as functions, okay, then we have these restrictions here, where this quadrant here doesn't even exist. Okay. For them to be functions. So for inverse cosine, all I care about, top half, because I have positive x values, negative x values. For sine and for tangent, I'm going to use the fourth quadrant and the first quadrant. For sine, I have in the first quadrant, I have positive y values. In the fourth quadrant, I have negative y values. For tangent, first quadrant, positive y values. Fourth quadrant, negative y values. But when I'm in the fourth quadrant, I have to use these angles here. Okay. All right, so let's answer some questions. So this says evaluate each trig function, give your answer in both radians and degrees. Okay. Main thing to notice is those letters. If they're capital letters, we're talking about the functions. Okay? And the functions are limited to those areas. So this says inverse cosine. So for inverse cosine, that means I'm restricted to the top half of the unit circle. From 0 to 180 in degrees, from 0 to pi in radians. So if you look at the top half of your unit circle, where does cosine equal negative square root of 3 over 2? In degrees and radians. Okay, 150 and 5 pi over 6. So my answer here is 150 degrees and 5 pi over 6. The answer in radians and degrees. Now I'm going to take good old letter B here, and I'm going to come back to it for a second. I'm going to change it for a moment. Okay. Put a radical there. Okay, so it's inverse sine square root of 3 over 2. Just for a moment. Okay. Sine. Fourth quadrant, first quadrant. If the answer is in the fourth quadrant, though, it's negative angles, not positive. Okay? So when does sine equal square root of 3 over 2 in that range? Okay, where? Positive square root of 3 over 2. Okay, at 60 degrees or, nope, pi over 3, because you got to give it both radians and degrees. Okay. Well, then the question they had here, I'll write it down as C, inverse sine of 3 halves. It's 3 halves on your unit circle for sine. No, it's not. Okay? And the reason is because our domain for inverse sine, inverse cosine must be between -1 and 1. Is 3/2 between -1 and 1? No, because it's 1.5. So this one would have no solution.
So if we see something like that, then we just write down the solution.
Yep. Because if you took your calculator, all right, if I took my calculator and let's say we're working with A. Now, I like degrees better than radians just because those numbers make more sense to me, okay? Which they probably do to you also, correct? All right, what's this pi stuff? Okay, I can understand 50 degrees, I can't understand pi. All right, that's fine. So for this first one, letter A, I could do inverse cosine negative square root of 3 over 2. There we go, 150 degrees. Hey, it gave me the right answer in degrees. It will give you the right answer in degrees. Okay? It's just that it'll give you a decimal number in radians that you would need to convert to make it correct. So your calculator will actually work there for you.